In the following sketch, ECH is a tangent to the circle ABC and C, and BC is a tangent to circle ABP at B. Alright, so you're given two circles here, the smaller circle and the bigger circle. Alright, you are given the tangent ECH. This is a tangent, right? It's a tangent to the circle ABC. This circle, the bigger circle, okay, the bigger circle, and then BC is a tangent to a smaller circle, circle ABP. Alright, that's the information that we're given, and now we need to answer the question. Prove that BC equals to CD. We need to prove that BC is equal to CD. Alright, and from the previous lessons I have said that to prove that lines are equal, you have to indicate. To prove that the lines are equal, you have to indicate in the diagram. Alright, indicate the lines that they are talking about. They are talking about BC. We'll have to indicate that line BC. Alright, look at the line BC. This is line BC. I have to indicate that it will be equal. This is BC, so they want us to prove that BC is equal to CD. This is CD. Can you see? I have indicated. So the most important thing is to indicate. Once you have indicated, then it becomes clear which angles should be equal. Because if BC is equal to CD, then BCD is an isosceles triangle. This triangle here is an isosceles triangle, and therefore it means that B1, alright, this angle here must be equal to angle D1. It means they're equal. So that's the aim. That is our goal, to prove that B1 is equal to D1. That is our goal. Can you see that indicating is very important? You have to indicate the lines that they're talking about. So then it means that, okay, for the first solution, question A, what we are required to prove here, that is what we are required to prove that angle B1 is equal to angle D1. So we said that you need to underline this, all right? So we're going to underline what you are required to prove. We're going to underline this, okay? What you're required to prove, you have to underline it. Then from there, you have to prove it one by one, meaning that you focus on angle B1, and then later you will focus on angle D1, okay? But now let's start with angle B1, right? So what is angle B1 equal to? You ask yourself, you are supposed to ask yourself that question. Angle B1 must be equal to angle A1, okay? That is the tan chord theorem. Look at BC. We know that BC, this line here, BC, is a tangent, right? We know that it's a tangent. So I'd suggest that you look at the chord. Look at chord BP, right? The most important thing is to look at chord BP. Look at chord BP. This is a tangent, but just look for the chord. This chord is opposite which angle, right? So this chord BP of circle ABP, the chord BP is exactly opposite to angle A1. So it means B1 is equal to angle A1. That is the tan chord theorem. So you look at the chord, right? That is the most important line. Then that chord is opposite to what angle? That's what you're supposed to ask yourself. So angle B1, we can see that it's equal to angle A1. Angle B1 is equal to angle A1. So our reason there is the tan chord theorem. So B1 is equal to angle A1, tan chord theorem. Now we are done with angle B1. Now let's go on to angle D1. So we can even tick that we are done with what? B1. But in the exam, don't tick, guys. Don't tick, right? Here I'm just showing you how this is done, okay? So let's go to angle D1 now. Let's focus on angle D1. Angle D1 is equal to what? Okay, we ask ourselves that. Okay, so angle D1 here, can you see that angle D1 is exactly equal to angle A1? Look at the bigger circle, the bow tie, right? Look at this bow tie here. I call it a bow tie, angles in the same segment. Remember, a bow tie looks something like this. This is a bow tie here. This is a bow tie, okay? And therefore, we know that angle A1 should be equal to angle D1. They should be equal because of this bow tie here. Can you see this bow tie that I'm seeing here? This is a bow tie that I'm talking about. So it means angle A1 is equal to angle D1. It's angles in the same segment. Right, guys? Very important to note. So angle D1 is equal to angle A1. This is just a coincidence, guys. It's just a coincidence that both of them are equal to angle A1, right? It's not always the case that they are going to be equal, right? So angle D1 is equal to angle A1. What is the reason there? It's angles in the same segment. So it's angles in the same segment, or you can say angles subtended by the same chord. That is the same, okay? Guys, Now you'll need to conclude with what you have underlined. Remember to conclude with what you have underlined. It's very important, right? So therefore, you have to say angle B1 is equal to angle D1 because both of them are equal to angle A1. Can you see? So therefore we have to conclude now. So we have concluded with what we have underlined. Angle B1 is equal to angle D1. All right. Why are we saying that? Because both of them are equal to angle A1. Look at that. B1 equals to A1, D1 is equal to A1. So both of them are equal to angle A1. Now remember to conclude with the question itself. Now we have to agree with the examiner. Let's agree with the examiner. Let's say therefore BC is indeed equal to CD, because if BC is equal to CD, it is angles opposite equal sides. Okay, so BC is equal to CD because of the converse of angles opposite equal to sides. You have to write that word converse, right? That's very important. Now let's go to question B. All right, now question B requires us to prove that BD is parallel to EC. Now I've indicated here, just like in the previous lesson, whenever they say prove parallel lines, you have to indicate the lines that the examiner is telling you about. All right, the examiner is telling us about the line BD. Go to the line BD. This is the line BD here. All right, indicate the parallel lines. Can you see I've indicated in pink? Those are the parallel lines. And BD is parallel to EC. Go to line EC and also indicate what is the symbol for parallel lines. Indicate there. All right. After indicating, try to look for a picture. We said if you are proving parallel lines, guys, you are required to choose from the three choices. Okay, you've got the alternating angles, you've got the corresponding angles, and then you've got the co-interior angles. Now after indicating your parallel lines here in the situation or in the diagram, you have to see which choice works the most, which choice works better. All right, we can see that we don't have a U here. We don't have a U. All right, after forming BD parallel to EC, we can't form a U here. It's impossible, right? And I said to you that a U, which is the co-interior angles, I said the co-interior angles, you only use that choice, or you only take that choice when you are given the center. All right, when you're given the center or the numerical values. Okay, however, the corresponding angles, which is an F, we don't have an F here, we can't form an F. So the only thing that I can see, all right, is the Z. It is the one that I can see that okay, it's working. It is the one that I can see and I am sure about that it is what it is working. So that is the Z. So look at this Z here. Okay, this is the Z that I'm showing. This is the Z here, is Z. Can you see? So meaning that angle C1 must be equal to angle B1. That is our aim and that is our goal. So it means our aim here is to prove if B1 is equal to angle C1. So that's what we're required to prove. We're required to prove that angle B1 is equal to C1 because you have drawn a Z there. Okay, after drawing the Z, then you can see which angles can be equal. All right, we're not saying they're equal, but we want to prove that they are equal. We want to prove that angle B1 is equal to angle C1. Now we're going to prove them one by one. We're going to start with angle B1, right? Now we ask ourselves, what is angle B1 equal to? We know that angle B1 is equal to angle A1. All right, we've proved that question A, right? In the first question, right? Question A, we have proved it here. All right, that is the tan chord theorem. So you can just say angle B1 is equal to angle A1. The reason is proven above. So that is the reason proven above, because we've proven it in the first question. Now we are done with angle B1. You can even tick it to show that we are done with angle B1. Right, now let's go to angle C1. Angle C1, ask yourself, what is angle C1 equal to? Can you see that angle C1 is equal to angle A1? All right, it's equal to angle A1 because of the tan chord theorem. Remember, this is our tangent. All right, and where is our chord? Our chord is BC, remember. So you have to touch the chord. Right, so we're focusing on the tangent and then the chord, but the chord is the most important line because the chord will help us trace the angle. Look at this. From the chord, where am I gonna go? I'm going to go A1. So you have to ask yourself, what is the angle that is opposite the chord? Chord BC. Can you see? The angle that is opposite chord BC is angle A1, meaning that angle C1 here must be equal to angle A1 there. Okay? Simple, right? Can you see how to deal with the Tanner-Chord theorem? That's how you deal with the Tanner-Chord theorem. Now, can you see that angle B1 is equal to angle A1, and also angle C1 is equal to angle A1? Both of them are equal to angle A1. Now we're going to conclude. Okay, we're going to conclude with what we have underlined. What did we underline here? Angle B1 is equal to angle C1. That's going to be our conclusion. All right. Therefore, now our conclusion here is going to be angle B1 is equal to angle C1. Why are we saying so? Because both angles equal to angle A1. All right. Both equal to angle A1, because both equal to angle A1. Alright, now we have to conclude with the question itself, guys. Now, what is the question saying? Question says, prove that BD is parallel EC. Now you are going to agree with the examiner. Alright, agree with the examiner. Say, yes, indeed, BD is parallel EC because angle B1 is equal to angle C1. Alright, so that's how we conclude the question. That's how we conclude with the question. BD parallel to EC. What is the reason? Converse of alternating angles. So the word converse, guys, is very important, especially when you are proving, right? Especially when you are proving, it's very important. Right, now let's go to the last question, question C. Prove that AC bisects BAD. Now, the most important word there is the word bisect. The word bisect means to cut into two equal parts, all right? That is the meaning of the word bisect, okay? If I am having, let's make an example of a rectangle, all right? Now, a rectangle, let's say this rectangle is a cake, right? This cake is in the shape of a rectangle. Now, if we want to share this cake here, all right, we'll have to cut it into two equal parts, okay? We'll have to cut it into two equal parts so that you can have piece number 1, and then I can have piece number 2, all right? So the word bisect means to cut into two equal parts, all right? That is the meaning of the word bisect. So the word bisect means to cut into two equal parts. Now let's go to the question itself. They are talking about line AC. Prove that AC bisects BAD. Where is line AC? Let us track this line here. This line AC, let's indicate it here. This is line AC. That's my line AC. They want us to prove if it bisects BAD, all right? BAD. They want us to prove that. Meaning, they want to see if A1 here, if A1, this angle here, is equal to angle A2 there. That's what they want us to prove, all right? So you'll have to draw a situation, sketch a situation in your diagram, all right? And therefore decide, just know the definition of keywords, all right? Bisect means what? Parallel means what? Equal means what, right? And indicate those symbols in the diagrams, all right? Then you'll be fine. You'll be able to answer the questions. So they want us to prove that angle A1 is equal to angle A2. That is our aim, guys. That is our goal. So that's what we're required to prove, guys. Angle A1 is equal to angle A2. Because if this line AC bisects angle BAD, so then it will mean that angle A1 must be equal to angle A2. That's what we're required to prove, right? Because remember, A1 must be equal to angle A2, which means they've been cut into halves. Those two angles are the same. They have been cut into equal parts, all right? So therefore, that's what we're required to prove. Angle A1 is equal to angle A2. Now we know how it goes, right? We need to prove them one by one. What is angle A1 equal to? We know that angle A1 here, angle A1 must be equal to angle B1, right? That is proven above, right? Proven in the previous question, in question A, right? The first question. So we're done with angle A1. Now let's go to angle A2, all right? Let's prove angle A2. What is angle A2 equal to? Angle A2 must be equal to angle B1 also, because of angles in the same segment. Can you see that? Can you see the bow tie, guys? Look at the bow tie. Angle A2 is equal to angle A1 because of the bow tie. Look at this bow tie here that I'm gonna indicate in pink, right? Let me indicate this bow tie in pink. Look at this bow tie that I'm indicating in pink, right? I'm going to indicate this bow tie in pink here. All right, can you see? Angle B1 must be equal to angle A2. That is the bow tie, or angles in the same segment. So that's what is happening there. So angle A2 must be equal to angle B1. That is angles in the same segment. Now we'll have to conclude with what we have underlined. Therefore, angle A1 must be equal to angle A2 because both are equal to angle B1, right? Now we are going to conclude. With the question itself. Therefore, AC bisects BAD. And why are we saying AC bisects BAD? Because angle A1 is equal to angle A2. That is the reason there, right? And ladies and gentlemen, that's how we prove those three questions, right? So thank you for watching. Please subscribe, like, comment and share. Right now, when you subscribe, it means that you will be notified whenever I post important lessons. Right, so please do so. Thank you for watching. God bless.